So we set up the reason we need another method because, well, when we have like 2x minus 6, the middle is not positive 6, the distance is not 20. We need to know what happens in this situation. And imagine if I turn this into like, oh, what if it was 4/7 x minus 3.58, equals, whatever random numbers I can make up, 20 over 17. You wouldn't really be able to say, okay, well, the middle is right here. I'm going to go this over here this much. It doesn't really work for anything else except these nice simple numbers when the coefficient is 1 and we have these nice integers, 3, 7, 10. Otherwise, not so great. So I'm going to show you an algebraic way, which means no graph. That will get you the same answer, but it's a little more powerful than the graph because it'll solve any problem, not just the simple ones. So we have a reason for knowing what we're about to do. Okay. So here we go. From before, I'm going to show you how we did last night and show you the equivalent for using only algebra techniques. So from here, we know the center is at positive 2. And from here, we know we're going to have an answer, one solution, that's 10 to the right, which will be at 12. And I'll know I have another answer, 10 to the left. 2 minus 10, which is negative 8. So from our technique from last night, using the graph, I know my answer is negative 8 and 12. And I could do a check and verify it, and it'll be fine. The question is, like, well, what if I change this to negative 2 over 7 and negative 103.578? Well, this wouldn't work just as quite as easy. So how can I get these answers without relying on a graph? Well, basically, I'm going to take the same information. On here, I had to do two problems. I had to figure out, well, what's 2 plus 10 to get 12, and what's 2 minus 10 to get negative 8. So I'm going to set up two equations. The only thing difference between these two is one is positive 10 and one is negative 10. So I'm going to set up two equations. One of them is going to be x minus 2 equals positive 10. And then I'm going to set up the other one, x minus 2 equals negative 10. It's the exact same work we did here. We just didn't write it out in an equation. But once we solve both of them, by adding 2 to both sides or doing any algebra we need to do to solve it, all right, we'll get, no surprise, okay, x equals 12, there's one of our answers. And then when we solve the second one, we expect to get the other answer, negative 10 plus 2, or 2 minus 10, which is negative 8. So we can get the same two answers without using a graph and still do a check, make sure they're correct if we need the problems we want. So in general, what you can do for each one of these, just set up the two equations. Just realize one's positive, but one goes to the right side, and one's going to be negative, one point to the left side. After that, everything else is review. We've done, we know how to solve an equation, whether it's one step, two steps, or multi-step. And we know when we get our two answers how to graph it. Just put a dot for each one. Just make sure the smallest is on the left, the bigger is on the right. And we know how to do a check for each one. We can go through and verify 12 minus 2, does that equal, absolute value, does that equal 12? And over here we can take our negative 8 minus 2, actually 10. And does that equal 10? So yeah, sure, we can still do a check and still make sure we're doing everything right. Again, this is the extra 2 minutes that's so tempting to skip because, oh, these are so easy, I don't need to do that. But yet, when we take the test, we're not going to have 100% of you get it all right. Somebody at some point is going to say, it's just not worth it. I had to do 4 more seconds of work. It's just not worth it. And it doesn't have to be that way. That's just a choice that some of you made. Most of you do make the right choice. Try not to be those, one of those, 3 people out of, 30 that will not do a check and get it wrong. Some of these easy stuff, they'll get it wrong just because it's too much to ask. Okay? Or your ego tells you, I'm too smart to do that because I usually get things right. Try not to do that. Okay? So here's a good example of the graph does not really work. With this 2 here, the center is not at 1. The distance is not 5. So, but we can still set it up as if it was. Like as we had a center, you can think of it as, okay, if I go 5 to the right and 5 to the left, positive 5, negative 5, I can set both of these up. 2f minus 1 equals positive 5, and 2f minus 1 equals negative 5. Now I just have two-step equations. Yeah.
So for this new step, you're not really plugging in anything in the infinite form, or the brackets in the.
No.
Just using the number. But
The nice thing about this is that it's the exact same algebra to solve both. Since the left-hand sides are always going to be the same on every time, so you're going to have 2f minus 1, 2f minus 1, the algebra to solve them is the same. They're both minus 1, so you both have to add 1 on both sides. Of course, the arithmetic is different because they're different numbers, but the steps are the same. So we get 2f equals 6, and 2f equals negative 4. Now, if you prefer just to do solve one, get one answer, solve the other, get the other answer, that's fine. But a lot of people like this side by side because they're just doing the same step on both, and line by line, it's the same step, and it's easier to kind of follow. So, but try both, see what you like. You don't have to choose now. So we know f is equal to 3, and same thing here. F is equal to negative 2. So my two answers are negative 2 and 3. So if you were to graph this, just make sure the smaller one's on the left, bigger one's on the right. You don't need to put anything in the middle, just a number line with 2 dots and the 2 numbers, as long as the small number's on the left, is perfectly fine. But you'll notice that the center is not positive 1, and the distance is not 5. I can't go from 1 and go over 5. That puts me at 6. That's not 3. So, by the way, what is the center of negative 2 and 3? A half. Yeah. And what is the distance? 2.5. Yeah. So, if you think of it this way, take the 1, divide by 2. There's your 1/2. Take the 5, divide by 2. 5 over 2 is 2.5. So you can kind of see the center, kind of see the middle, and kind of see the distance, but it gets a little abstract. So better to stick with some algebraic approach. But it still has a center. Be careful, don't say, well, negative 2 and 3 doesn't have a center because it's not even, like it's not an integer. Any two numbers have a center. You can take the middle of any two numbers. It's called the average. So if you take negative 2 plus 3 and divide by 2, 1 over 2. Okay? And of course, I'm not doing this, but I expect you guys to do this. Do the check. So below you can do 2 times 3 minus 1, absolute value. Does that indeed equal 5? And then does 2 times negative 2 minus 1 equal 5? Okay. Question mark. If true, then they both work. You're correct. If one doesn't work or both false, sums up. All right, let's have you guys try. Yeah. Let's start here. So we saw our two answers. We know one is positive 5, one is negative 5. And the left-hand side does not change because the left-hand side represents the center. So we don't want to make any changes ever. The center is always going to stay consistent. We're just trying to go to the left and the right in the same place. All right, and after you solve both of these, you get n equals 7 over 3, which you can leave as 7 over 3. Okay? And on the right-hand side, you get negative 1. And since one's negative, one's positive, we know negative 1 is less, so that goes on the left side. And you know, I can put my answers far apart, close together. It really doesn't matter. As long as I have 2 dots and the smaller one's on the left, that's perfectly fine for your answer. And this is your total answer. Don't mark the middle. The middle we just marked before, so we know where to go to get to the answer, but the middle is not part of it. And that will conclude it. Of course, you have to show your work or check. 3 times 7/3. 3's cancel out. 7 minus 2. No problem. One of my big pet peeves is people saying, well, this problem's harder because it has a fraction. It involves 5th grade math, so we're going to say this algebra problem for our freshmen and sophomores and juniors is more difficult because of something we learned between recess and lunch. This is not more difficult. Don't tell yourself that, and it won't be, I guarantee. A lot of people tell themselves because years ago it was, and they just got in the habit of saying it is difficult when it's really not. Okay? So just to prove that point, let's do another. Okay. So my 2 equations are here and here. Come on. So I have to add 3/4 to both sides on both. Remember what I don't want you saying. You can say I don't remember. You can say, you know, sometimes I get it wrong. Just don't say this is difficult. Thank you. Or this is hard. So seriously, ask yourself, to do this, you have to do 1 plus 3 or 3 plus 1 and get 4. So if you say this is difficult, you're saying 3 plus 1 is difficult and that's too much. Same thing over here, we have to do 3 minus 1 or negative 1 plus 3. 3 minus 1 is 2. So if you're saying this is difficult, you're saying I can't do 3 minus 1 and then reduce it. So it's okay to say maybe I don't remember, or I'm not good at it. Don't tell yourself it's too difficult. Thank you. So we got 1/2 and 1. That's it. Okay. Nope. Almost done.
You do this one right. Wait, how do you check? How do you check?
How we check?
Huh, I was right. I bet it
Yeah, but
oh, yes.
yeah, no, you just saw it. Because it was on your band. I was like, not even that way. People have been telling us that.
So here's what check looks like. Remember, this is not optional. So if you said I got the right answers and you didn't do any of this below, expect half credit. 50% is half. You must do all of it. You must do the checks, period. So if you're one, again, that says, well, I'm not so good at this, I know I can see now maybe it's easy that it's just basic arithmetic, 4 plus 3 plus 1 and 3 minus 1. Write this down. Make sure you have it. So when you come to it on your homework, you're not coming in tomorrow saying, well, that one I couldn't do because I didn't want to write down the notes yesterday. That's not going to be a good excuse for me anyway. Okay? So make sure we got all this. And the only thing that was in the checks that's not in everything else is right here. You have to know that 1/2 is the same as 2 over 4. So as long as you can do that, okay, well 1 over 2, that doesn't work with 3 over 4, but the same thing as 1 over 2 is 2 over 4, and they're both half, both equal 0.5. As long as you do that, 2 minus 3 is -1. Absolute value is -1/4 is +1/4. That's it. So all together, you had to know several things. You had to know 1 plus 3 is 4. You had to know 3 minus 1 is 2. You had to know how to reduce it. And if you can do this part, you can do the check. If you notice, the check is this in reverse. We go from 1/2 minus 4/3. But look at the step before that. It's 2/4. So we go from 1/2 to 2/4. You're just doing this in reverse. Instead of adding 3/4, subtracting 3/4. So if you have all the work of this, the check is the same thing. It's just going up. Just everything's going backwards. Instead of reducing 2/4 to 1/2, I have to change 1/2 to 2/4. Instead of adding 3/4 to both sides, I have to subtract 3/4. So you do the problem forward, get an answer, and if you get the same answer doing the problem backwards, kind of like they agree with each other, so you know it's correct. Okay. So another way of looking at a check, and it's the same thing over here. We have 1. In order to do this problem here, I've changed this to 4 over 4, so I can do 3 minus 4 to get 1/4. Okay, so I'm just going from here, and then subtracting 3/4 to show my work. Moving on, real fast, what is this?
No solution.
Distance cannot be negative.
I knew that one.
Doesn't matter about this 4, no difference. Okay? No so. What is this? Now, what does this mean? Don't start off with, don't think the first thing is, okay, I'll do this to both sides, we'll get 2 equations. Start off with what it means. The distance equals, so how many answers are there?
0.
One.
All those numbers.
Let's see.
Could it be?
The left represents the center, the middle, right? That hasn't changed. So this is saying starting at some point in the middle, and you're going 0. You're not going anywhere, so you're just staying at the middle. Make sure you understand that. It's not like a surprise, like, well, that doesn't make sense. I'll just follow the steps and get that answer. It should make sense that you can't go negative, so there's no solution. If you start at the middle and you go nowhere, you're still at the middle. So you have one solution. So there's a pattern here, is that if the distance here, if it's 0, that leads to one solution. And we saw on this before here, if the distance is negative, okay, there is no solution. And if the distance is positive, we have 2 solutions, one to the left, one to the right. And this relationship exists not only with absolute value but with a lot of other graphs, and we'll see it again. Okay? But it's very, very common. Just know that there's different possibilities. I don't want you to memorize this and say, okay, negative means no solution, 0 means 1. I want you to understand that you can't go negative distance. That's why you can't have an answer. If you're standing still and you don't go anywhere, you go 0 distance. Well, the answer is where you started at. You haven't gone anywhere. And if you're at the middle somewhere and you go the distance, you can go to left or right. That's why there's 2 solutions. So this is a summary of all that backstory, all those meanings, not just a table just to remember for a week and then over the weekend you forget it.
So whenever it's 0, do we put the solution or do we just?
Yeah, just like this. Just like this. Yeah, it's 6. You can't do a +0 and a -0. There's no such thing. It's just an answer. Okay. But just like on the task, I want you to be able to explain this to me on why does this exist. Not just say, how many solutions are there if it's negative? Oh, there's no solutions. Good job. That's like barely scratching the surface. Tell me that absolute value is distance. Distance can't be negative. That's why there's no answer. Okay? All right. So that can